Hello everybody, I'm here with a little bit different video than I've done in the past. I'm going to go a little bit deeper into one specific math topic, in this case the quadratic formula discriminant. And the reason I'm doing this now is I just got a comment on one of my previous, the full SAT videos, problem 36 on practice test 10, section 4. And what I did in that video was there was a quadratic, it was a problem involving a quadratic, and what I did was I used a little bit of calculus to come up with the answer. And I realized that's really not fair because you don't need calculus to do the SAT, and there is a way to solve this problem without calculus. And this comment here called me out on that and said, could you please explain the way to do this problem without calculus? And first, you have to have a little bit of information on this quadratic formula discriminant, which you may or may not have covered in your Algebra 1, Algebra 2 class, but we'll review that right now, and then I'll show how to solve this problem using that concept. So let's jump into it. So what does quadratic mean to start with? So a quadratic equation is defined by an equation where the x term has a maximum of squared. So it has a maximum of to the power of 2, and it may or may not have a single x, and it may or may not have a constant, but it does not have an x to the third, x to the fourth, anything to a higher power. So it'll often look like this, where a, b, and c are constants in this equation. And you've probably seen this in your Algebra 1, Algebra 2 class. So one thing that you need to have memorized going into the SAT, it'll show up usually on 1 or 2 problems in the SAT. You'll need to use this, usually towards the end of the problems, this quadratic formula. And it's a way to solve for x for any equation that takes this form. So you can use these constants alone to solve for x. And one important part of the quadratic formula that you need to use for this specific problem, this problem 36 in particular, is the quadratic formula's discriminant. And what the discriminant is this bit inside or underneath the square root in particular. And why this is important is this discriminant can tell you how many and what type of solutions x takes. Because there's a squared term, it can take 2 different solutions, or it will have 2 solutions, right? So if this discriminant is positive, it means that there are 2, if discriminant is positive, it means there are 2 real solutions to the quadratic equations. So why does this happen? Let's take just a second and think about why this happens, because it'll lodge in your brain better if you understand why. So think about a square root. If there is a real number underneath the square root, let's say this all works out to be 4, so the square root is 2, and then you have this plus or minus sign here, that means that you're going to have 2 real solutions, one where you add that 2 and one where you subtract that 2 real solutions. If this discriminant is 0, it means that there will be 1 real solution. Or you can also think of it as 2 solutions that lie on top of one another. But there will be one number that's a solution to this. And you can think about that as a square root of 0 is 0. So plus or minus 0 will always be 0. So you only get 1 number out of that for what does x equal. If you have a negative number for this discriminant, you will not have any real solutions, or you have complex solutions. Because you cannot take the square root, right? It's a complex number when you take the square root of a negative. You're unlikely to see anything like that on the SAT. Usually what you're going to have to use is that this discriminant will either be 0 to get you 1 solution or positive to get you 2 solutions. And that's the information you need to know to solve problem 36. Before I jump off of this slide, I'll just say it's really handy. Like I said, memorize this quadratic formula going into the SAT. If it's just information overload, what you can do is memorize this when you go in. As soon as you sit down for your SAT, get into the math section, write this on that first page they give you some geometry things. If you think you're prone to forget this in the heat of the moment, write this down right away. Just write down this negative b plus or minus square root b squared minus 4ac all over 2a. And then you'll have it for at the end of the test when you're worn out. And you get to something that needs a quadratic formula. And you know that you'll need it if you see a quadratic equation that takes this form here. Okay, all that said, let's get to using this to solve that problem 36 from practice test 10, section 4. Jumping into the actual problem, again, this is problem 36 from practice test 10, section 4. In the xy plane, a line has the equation y is equal to c for some constant c intersects a parabola at exactly one point. If the parabola has the equation y is equal to negative x squared plus 5x, what is the value of c? So starting at the top, in the xy plane, draw yourself an xy plane in your mind or on the test. I'd probably draw it on the test. You give yourself an xy plane. A line has the equation y is equal to c. Change color here. That's a constant line, horizontal line, constant at c. That should be a constant straight horizontal line. I just can't draw. Intersects a parabola at exactly one point. That means the intersection has to happen at the vertex of the parabola. If it happened anywhere else, it'd be going through both legs of the parabola. It would have two solutions. So what does that look like? It comes down, it touches at exactly one point, and goes back up. So your one solution here happens at y is equal to c, because this entire line is at c. Okay, back to the words. If a parabola has the equation y is equal to negative x squared plus 5x, what is the value of c? What they're looking for in the end is the value of c. You know this one solution here, which means that you can take this y, plug it into this y, plug this equation into this. Leaves you with c is equal to negative x squared plus 5x. By now, because this equation only has an x squared term, because factoring does you no good, it should clue you in that you're going to be using your quadratic equation, quadratic formula here. So set it to the form you're used to seeing a quadratic equation in, meaning move the c over to the right side, so subtract c from both sides. 0 is equal to negative x squared plus 5x minus c. I'm going to take one more step to make this easier and multiply everything by negative 1. If you don't take this step, everything still works out. It just causes a little extra work. But multiplying by negative 1 puts it in the most common form you're used to seeing, so take that step. So 0 is equal to x squared minus 5x plus c. Again, that was just everything by negative 1. So now, remember your quadratic equation form. Y is equal to ax squared plus bx plus c. And use that to pull out those constants from this equation. So a is just equal to 1. B is equal to negative 5. Right? A was equal to 1. B was equal to negative 5. And c we do not know yet. So c is equal to unknown. That's what we're looking for here. Now you can use your quadratic formula. And remember your quadratic formula form. You have x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And what's important here? The problem tells you the parabola intersects at exactly one point. There's exactly one solution. And what did we learn about the discriminant? It means that if there's only one solution, it means that what is under the square root here has to be equal to 0. That's the only way that this gives you one solution. So this is equal to 0. You can pull that out, write it again. 0 is equal to b squared minus 4ac. Use the a and b that you found from the equation they give you in the problem. So you have 0 is equal to negative 5 squared minus 4 times 1 times c. You'll be left with 0 is equal to 25 minus 4c. Add 4c to both sides to isolate the c. You'll be left with 4c is equal to 25. And finally, divide both sides by 4. You'll be left with c is equal to 25 divided by 4, which is the correct solution to this problem. Now, I know that's very involved. Again, the quadratic formula shows up maybe once or twice per SAT. Knowing this discriminant trick is equal to 0. You know, I've done 3 videos of these SATs. This is the first one using that discriminant specifically has showed up on. So it's not like you're going to lose a ton of points if you don't know this specific thing, but now you do. Keep it in your back pocket. Anytime you see a formula that sets up like this and they're asking you to solve for one of its constants, anytime you see a quadratic and they're asking you to solve for one of its constants, think to that discriminant. Think to, okay, if they say that it has only one solution, I know I can set it to 0. I really hope that helps. I hope to record more videos of actual full SAT tests soon. So go ahead and subscribe, like this video if it helped you. Thanks a lot. Have a good one.